Okay, see if you guys can work this out. I've got a bag of sweets here, and there are six white sweets, three purple sweets, and two black sweets. So I'm going to jumble up all the sweets in here. I'm going to put my hand in here and take one out. Okay, I will take note of the color, and then I will put the sweet back, jumble up everything again, and then take another sweet out at random. Okay, take note of that sweet, and then I'm going to put it back, and then jumble everything up again, shake it up all about, and then take another one out. So in effect, I'm taking out three sweets. What is the probability of me getting at least one white? So it could be a white, white. So this is a good outcome. Or white, black, purple. This is a good outcome. So at least one. Okay. What is the probability of getting at least one white? So at least one, meaning one white would be a good outcome. Two would be also a good outcome because it's at least one. Okay. So three white would be a good outcome. Okay. So given this situation here, what is the probability of me getting at least one white? Remember, I'm putting it back each time, and then jumble it up. So I'm returning the sweet each time. Okay, so I'm going to pick out three sweets, and what is the probability of me getting at least one white? So press pause and have a go. Okay, so as always, draw a map of all the things that could happen. So here we on our first dip. So on the first time we put our hand in here, we could get a white, we could get a purple, or we could get a black. Okay, but the thing is, the question is saying, what is the probability of us getting at least one white? Well, now we can actually merge the purple and the black together because, well, we don't really care. We don't really care about it being purple or black. We just care that it's not white. So with our diagram, let's start again here. So we are going to put our hand into this bag. Yes, there are three outcomes, but we're just going to simplify it to white and not white. Okay, so purple and black being not white. Now the probability of it being white is 6/10. The probability, so 6/11, because there are 11 balls altogether, 11 sweets altogether. So 6 out of 11, and the probability of being not white is 5/11. Okay, now so we just picked out one ball. Now we've got to put the sweet back in here, and then jumble up everything, and then take another sweet out. So on a second dip, it would be white or not white. Again, it would be 6/11. Not white would be 5/11. Okay, and then this here would be white, not white. Again, it would be 6/11 and 5/11. And now on a third dip, remember we are returning the sweet each time. So on our third dip, it could be white, not white, and then white, not white, and then white, not white, and then white, not white. Okay, and each time it's 6/11 here, 5/11 here, and so on. Now, which branches are we interested in? Well, white, white, white. This would be a good outcome here. White, white, because white is at least one white. So this would be a good outcome. White, white, not white would be a good outcome. White, not white, white would be good outcome. So white, not white, not white, that's a good outcome because you've got at least one here. Basically, all these apart from not white, not white, not white. So this would be a good a bad outcome. All the rest are good. Okay, so remember, when it's an and, you got to times. When it's an or, you got to add. So now you got to get this root. So you need white, white, white. So you got to get white, probability white, white, white here equals, well, a sixth. 6 over 11 times, because you need a white here and a white here and a white here. So when it's an and, you got to times. Okay, so times 6 over 11 here. Okay, and then this will give you whatever, and then you need probability of white, 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 and not white. So white, white, and not white. So that would be 6 over 11, because you need this and this and this. So one whole branch, you've got to times everything. So it would be this, and then times, well, the last one is 5 over 11, okay? 5 over 11. That will give you blah, blah, blah. And then you got to do all the other branches, all the good branches. And then realize that you need an or, because you could go down this route or this route or this route. Okay, so when it's an or, you got to add up all these together. But rather than doing that, because I know that the only bad one is not white, not white, not white, and I know that if you add up all the branches, it must come to 1. So I'm just going to work out. I'm just going to do this. Probability of at least one white equals, well, I'm just going to do this. 1 take away the probability of not white, not white, and not white. Because rather than me adding up all these branches, this add this, add this, add this, blah 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 blah, I'm just going to work out this branch and just get 1 take away this branch here. Okay, so what is the probability of so probability white equals 1 take away. What is the probability of not white, not white, not white? Well, I need this and this and, well, 5 over 11 here. So basically, the probability of not white, not white, not white would be what? Would be 5 over 11 times 5 over 11 times 5 over 11. Okay. Well, you can imagine it like this. So let's jump to a calculator. So it would be 1 take away 5 times 5 times 5. Hang on. So clear it. 5 times 5 times 5 equals 125. 125. Over 11 times 11 times 11. So 11 times 11 times 11 equals 1331. Okay. Hang on. So now clear. So 125 divided by 1331 equals 0.939. 0.939. Okay, so but this here is actually this. So now I just need to get 1 take away this number here. So it will be it will be 1 take away that number. So let's clear it. 1 take away 0.0939 equals 0.9061. So it's going to be roughly this. About 91%. So probability is roughly 0.91. So going back to this situation here, the probability of you getting at least one white is 0.91. So it's very likely you will get at least one white. Okay, it's very likely that you will get 0.91 if you take out 3 balls. Okay.